In today's lesson, we're going to learn about absolute value equations and inequalities. So first and foremost, let's define what absolute value is. It is going to be the distance a number is from zero on a number line. It's going to be the distance a number is from the zero. So when we're talking about distance, we'll always want it to be positive. For example 1, we're going to solve and graph when we have the absolute value of x equaling 7. So remember that is a distance of 7, and that can happen for two occasions on our number line. First is when we have a positive 7, and second is when we have a negative 7. Both those distances will be 7 away from 0. So both will have a distance of 7. How we write this and solve it for x is saying that x can be positive or negative 7. So taking that 7, when we take away the absolute value, we have to account for we can have a positive 7 or a negative 7 being the same distance of 7. We finish our graph for example number 1 is just plotting the points where x would be negative 7 and x would be a positive 7. That's how we'll graph those 2 points. X can be positive 7 or x can be negative 7. For example number 2, we want to solve and graph x minus 17 equals 38. So a little bit more than the example 1 because we have a negative 17 inside of our radical. So what we are going to go ahead and do is take that outside of the radical and say that it's equal to a positive 38, and it also can be equal inside to a negative 38, resulting in the same distance of 38 from 0. Then we just solve that one-step equation, each one of them. So when I add 17 over here, when I have positive 38, I get my answer to be 55. And then over on my left, when I have the negative 38, I will still add 17, but instead of 55, I get a different result, which is going to be here, negative 21. We go ahead and graph this, showing that our possible x value will be at the point of negative 21, put a point there, and at positive 55. And again, this is just a sketch of our graph here, but make sure your negatives are on the left and your positives are on the right of 0. From here, we're going to go ahead and solve and check this one. No need to graph it, but solve and check. So first and foremost, I need to account for both solutions here. So I will write 6x plus 5 equals a positive 13, and 6x plus 5 equals a negative 13. It's so important that I am changing nothing inside my absolute value. The only thing I'm changing in each equation is a result of positive 13 and negative 13 because that means a distance of 13 both times for my absolute value. I just have to figure out what my value of x is. Over here, I'm going to subtract 5 from each side, getting me 6x equals 8. Then from here, I divide by 6. Yes, you can get a fraction. Our result here, when we simplify it down, dividing 2 in the numerator and then the denominator, I'll get 4 over 3. Always put a simplified fraction. Over here, when I have the result of negative 13, it's still a distance, but negative 13 is still a distance of 13 on my number line from 0. So I subtract 5, 6x equals negative 18, divide by 6, and I get my answer to be x equals negative 3. So again, we do not need to graph this one, but let's go ahead and check our work here. How I would check it is plug it back in these x values to my initial absolute value equation. So I plug in 6 times 4 over 3 for x plus 5, and I want to see if it's equal to 13. Well, remember when we have a fraction, you can write 6 over 1 to being the same thing as 6, and we multiply the numerator, multiply the denominator. 6 times 4 is 24, and then 3 times 1 is 3. 24 divided by 3, let's just do that simple math quick to get 8 plus 5 would indeed result in 13 being equal to 13 here. That checks out. We can also check this one here. I will move a little bit into my next problem space just to make sure I have enough to write this. We're going to check now if I plug it back into my original, that x value of -3. See if that again results in a distance of 13. Now that I plugged in -3, we'll do the math of that. We get -18 plus 5. That is going to give me a -13 in the absolute value. But remember, absolute value tells me the distance a number is from 0, and that would just result with 13 equaling 13 again. So if you get both sides to equal each other, you have the correct checking of your x values. For example number 4, we want to solve and check the absolute value of x plus 7 is equal to -11. But thinking about it real quick and looking at our important note here, let's highlight it here. It is important that if the absolute value is isolated, meaning it's all alone, it's not being multiplied, subtracted, or added, and it also is equal to negative, there is no solution because absolute value is a distance and distance will never be negative. You can't say you're going a negative distance to, if you were going to school, you can't say you're going a negative distance. Can't have negative distance here. It would be weird to say I'm going -13 miles to a place. That's not possible, and that happened here. So again, it happens when your isolated, all alone absolute value, which it was here, nothing was multiplied, added, or subtracted to it, and it resulted in a -11 distance. Cannot have that -11 distance, so we say no solution. You could write it out or put our no solution symbol. We're going to talk about extraneous solutions, which is going to be, by definition, an apparent solution that is false because it doesn't satisfy the original equation. So basically, we're going to solve these algebraically. Then in our check, we're going to make sure it came out like our last check, where it was 13 equals 13, your number equaled each other on each side of that equal sign. So let's go ahead and do our steps algebraically. So remember, take what's inside my absolute value unchanged outside of it, but then you have to account for the distance, which is the same negative from 0 as it is positive from 0. So what I'm going to do is take this 2x plus 4, keep it positive, but then I'm going to write my second equation, second solution. Everything inside my absolute value stays, but what's going to happen now is I'm going to have to talk about the negatives here. We go ahead and solve one equation at a time. Let's go ahead and start left to right. To get x by itself, we subtract 2x on each side, getting us 2x plus 5 equals 4. Subtract 5 on each side, gets us a -1 on the right side, 2x on the left, where we divide by 2 to get x all by itself. So here we have x equals -1/2. We can go ahead and check that one before we start on the other. It doesn't matter what order you go in, but let's check that first. Make sure we did our algebra correctly, or we have an extraneous solution. We plug it in. 4 instead of x, I have -1/2 plus 5 in my absolute value, and it will equal 2 times -1/2 plus 4. I'm replacing every time I have x in my original equation with -1/2 my solution. From here, we go ahead and solve. 4 times a -1/2. Remember, 4 can be written over 1 to make that a -2 plus 5 equals, remember, 2 can be written over 1, giving me a -1 here plus 4. -1 plus 4 is 3. -2 plus 5 is absolute value of 3, which is 3 there. So that checks out. Let's go ahead and solve our second solution here. So I'm going to start here by distributing my negative, but also to make sure this is a plus. I wrote it incorrectly and just caught that. So make sure to distribute the negative to both terms. It has to go to the 2x to make it -2x and the 4 to make it -4. And then my left side was untouched as 4x plus 5. We move my variables to one side, so I'll add 2x and then subtract 5 because I want to move that number over. Numbers on one side, variables on the other. I get 6x is equal to -9. From here, I divide by 6. I can simplify this down when I divide 3 by both the numerator and denominator, making it -3/2 as my x value. We'll now go ahead and do our check, and this is where we would catch if it's extraneous or not. But let's go ahead and check. So we are checking that in my original absolute value equation, instead of x, I'm replacing it with the value of x I just got, which is -3/2, for every time I have x in this original equation. Then we go ahead and solve. When I do 4 times that -3/2, remember, 4 can be written as 4/1, and you multiply across the numerator and denominator. So we get a -12/2 because 2 times 1 is 2. We add 5 to that, and it's going to equal again. This can be written as 2/1, so 2 gets multiplied to the -3 in the numerator, making it -6, and 2 times 1 is 2 in the denominator. We go ahead and divide. I get -6 plus 5 here and -3 plus 4. Well, -3 plus 4 is 1. -6 plus 5 is a -1 in the absolute value. But remember, when we get rid of those absolute values, when we evaluate it, it is the distance of 1. Can't have a negative distance, so it's a distance of 1. -1 is 1 unit away on my number line from 0, and so is 1. So that is checked and verified here. Those were both true, no false extraneous solution there. In example number 6, we're going to go ahead and solve and check the absolute value equation. Remember, to solve, we go ahead and keep the expression the same inside the absolute value, and we set it equal to the 11 plus 3x. Again, since the absolute value is all alone, we set our second equation, second possible answer, 6 minus 2x, equal to the negative of that expression. So make sure you put a negative and then parentheses around the expression so you know the negative goes to both terms. When solving the equation on the left, we go ahead and combine like terms by subtracting 6 from each side. And then I would get 11 minus 6 to be 5 and 6 minus 6 to be 0. I want to combine my x terms by moving -3x over to the other side to cancel it out from the right side. And combine it on the left side, -2 minus 3 is -5. To separate the -5 with x, we go ahead and divide -5. What we do to one side, we do to the other, canceling out to a -1. We go ahead and do our check of this possible x value solution by plugging it back into the original problem. 6 minus 2 instead of x, it's a parentheses -1. And then we equal it to 11 plus 3 with a parentheses -1. Solving it here on the Left side, we have 6. Do the multiplication first. That's our PEMDAS, telling that -2 times -1 is 2. And on the right side, same thing. We're doing PEMDAS first. So we do the multiplication of 3 and -1 to get us -3. We go ahead and get the absolute value of 8 equaling 8. And remember, absolute value is a distance, giving us 8 equaling 8, a true statement. Let's go ahead and solve this second possible solution. So we keep the 6 minus 2x on the left side, but because we have a negative that we're going to be distributing to everything on the right side, we now have it as -11 minus 3x. We go ahead and solve this by subtracting 6 on each side and adding a 3x on each side. 6 minus 6 is 0, canceling out, and -2 plus 3 is a 1x. -11 minus 16 is -17, and the -3x plus 3x cancel out. We go ahead and check this solution by plugging it back into the original equation. Absolute value of 6 minus 2, parentheses, -17, equaling 11 plus 3 times our -17. We go ahead and see on the left side, we do the multiplication as part of our PEMDAS first to give us our 34 that we will add to 6 in the absolute value. Order of operation tells me to do the 3 times -17 first to get a -51. Combine our two terms, we have 40 equaling a -40. And remember, we talked about that it's a distance, so it can never be negative, making this a false statement. That's going to be our case of extraneous, so I'm actually going to not circle this as a possible answer. It is just an extraneous answer. So my only number of x that would work this time is going to be -1. -17 is extraneous. It's important to note that sometimes you need to isolate the absolute value, which means get it by itself, before splitting it into the two equations we have been to solve. You'll notice that up until this point in our notes, we've had the absolute value already by itself. Now you see here it's multiplied by 3 and subtracted by 5 on that same side of the equation, so we'll have to move both of those. The first one we'll have to do is the subtraction of 5 because it's not directly attached. It can be easily moved by adding 5 to each side. Cancels out on the left, and we have 15 on the right. I'll bring down everything else I have left on the left side here. Now what's directly attached to the absolute value is the 3 that's multiplied in front of it. So dividing each side by 3, since the opposite of multiplication is division, getting my absolute value finally by itself equal to 5. Remember, this is when I now split into the two equations. My first equation is going to be keeping the expression in the absolute value the same for w minus 1 and setting it equal to a +5. And then second split is going to go ahead and be still keeping the expression inside the absolute value the same for w minus 1, but equaling it to a -5. And we solve each one separately. First one here on the left, I will add 1 for each side. 4w is now equal to 6, and I will divide each side by 4. That cancels out on the left, and I'll simplify my fraction on the right because I know 6 and 4 are both even numbers, so they're divisible by 2, giving me 3/2 as my simplified fraction. We'll go ahead and solve the right side here, or right equation specifically, by adding 1 to each side. 4w now equals -4. And we divide by 4 to get wi by itself, and -4 divided by 4 is -1. We must do our checks to make sure that these are both true answers, that we don't have any extraneous cases. So we're going to go ahead and check both answers. We'll start with the one I solved first. You plug it back into the very original problem. 3 absolute value 4 instead of w, that will be 3 over 2. Minus 1, close that absolute value, minus 5 equaling 10 here. Remember, I'll put 4 over 1 so I can multiply straight across the top and straight across the bottom of that fraction to get 4 times 3, which is 12, and 2 times 1, which is 2. Still keep the subtraction of 1 inside the absolute value, minus 10, minus 5 equaling 10, not in the absolute value. Division again in that group is my order of operation that comes first here. So I'll do 12 divided by 2, which is 6. Keep the subtraction of 1 inside the absolute value. Next step is getting that absolute value down to a single number. We know 6 minus 1 is 5, and the absolute value of 5 is 5. Next thing is I'm going to do my multiplication first of 3 times 5, which is 15. When I do 15 minus 5, that is indeed 10 here. So that checks out. Now we got to check that second solution, make sure it's a true solution and not an extraneous, aka false one, by plugging in a negative 1 into w in my original given problem. Order of operations tells me to do what's inside the absolute value first, but multiplication specifically, think about your PEMDAS or your GEMDAS. Negative 4 minus 1 is a negative 5 inside that absolute value. But we know the absolute value of negative 5 would be 5 since it's talking about the distance negative 5 is on the number line. Again, PEMDAS GEMDAS tells me to do the multiplication of 3 times 5 first before I subtract negative 5, getting me 10 equal to 10, a true statement, making that solution a real true solution. Next example, here we go. We do not have the absolute value again by itself here, so we have to move everything away. Remember, just like the last problem, I have to move what's least kind of close to it, what is kind of unattached, which is just this plus 4, making it easier to subtract 4 on each side. Keep the negative 5 that is attached by multiplication to that absolute value. And 14 minus 4 is 10. Now I divide each side by negative 5 because that's the opposite of multiplying it by negative 5. And I finally have my absolute value all alone, which is 3x minus 7, equaling to 10 divided by negative 5, which is negative 2. Now be careful because this is our special case. That special case was at the very front of our notes. It's important to know that if an absolute value is all alone and isolated, which we just did, and equal to a negative number, which we have a negative 2 in the problem, it is no solution because the absolute value is a distance and will never be negative. So the answer for this, like I just mentioned, is no solution, and you can denote it whichever way you prefer. Last example, here we go. The absolute value is not by itself, it's divided by 2, so we have to do the opposite, which is multiplying by 2. What you do to one side, you do to the other. That cancels out to the absolute value left alone on the left side, and 4 times 2 becoming 8 on the right side. We split it into our 2 possible answers. Remember, it is so important that we keep the absolute value expression of 2x plus 6. It will be equal to a positive 8, and that same 2x plus 6 will also have the possibility of being equal to a negative 8. We solve each one down. We go ahead and subtract 6 on the left and right sides. Bring down the 2x, and 8 minus 6 is 2. To separate the x to get it out by itself, we divide each side by 2, leaving x equal to 1. In the second possible equation, we subtract 6 on each side again, but now I have 2x left on the left and negative 14 on the right. And I divide each side by 2, getting x is equal to negative 7. So remember, these can both be possible true solutions, but we plug it back into the original given problem. to check to see if it's a true solution or not. Checking the first one we solved for by plugging it in the original problem where x is located. Remember, you're going to do your PEMDAS or GEMDAS order of operations here. So I do my multiplication inside that absolute value to get 2 plus 6 now, because 2 times 1 is 2, and I keep everything else as is. I now add the 2, which will get me the absolute value of 8. When I divide the absolute value of 8, which will come out to be a regular 8, by 2, it will indeed be 4. Making that a true statement and making that a natural solution. We check our x equals -7 to see again if that is a true solution. Plugging in the x everywhere you have an x variable in your original problem. Again, PEMDAS tells me to do the multiplication inside my absolute value first. Then I'll combine it to a -8 inside my absolute value. Remember, when I take the absolute value of -8, it's the distance, so that will be a +8. Therefore, when I do have 8 divided by 2, it will be 4, equaling the 4 on the right side. Another actual true solution. No extraneous solutions here.